Hello class, welcome to a very brief tutorial on how to form a hypothesis. My name is Valencia Cody Barker and I'm one of the full-time remote assistant professors here at Ashford University. I will be assisted today by my friend Jenna. Jenna has a question about fish behavior and she would like some assistance with forming a hypothesis. Before we can assist Jenna, let's have a quick review of the scientific method. I am 100% sure that you've reviewed this information in your textbook, but as a refresher we'll go over it again just in case. Remember, the scientific method always begins with an observation of a situation or a problem. We form a hypothesis, and we'll be working on that more today, followed by an experimental procedure where we gather and analyze data, and then we draw some conclusions. So let's make sure that we fully understand what a hypothesis is before we help Jenna. A hypothesis is a supposition or a proposed solution or prediction to a particular scenario. So yes, it's correct to say that it's a prediction statement, but it's a very structured, formal type of prediction statement. And there are two key components of a hypothesis. You must have experimental variables, both dependent and independent, and your hypothesis must be measurable or testable in some way. So keep those two keys in mind as we help Jenna. So Jenna has observed for us that fish sometimes leap from the water, and she has also observed that there are items near these fish, such as a snake or soda cup or donut. So let's go back to our keys. First of all, those variables. Let's identify the experimental variables here. We have a dependent variable, which would be the fish, because that's the target organism or what we're interested in. And then anything that may potentially influence the fish behavior, then that would be the independent variable. In this case, we have several independent variables: Jenna, the donuts, the soda cup, and the snake. Next, let's see if we can write a measurable scenario or a testable hypothesis. Let's go, Jenna. Fish sometimes behave strangely in lakes. Well, the problem here is we have a dependent variable, but we don't have an independent variable, and it's nearly impossible to measure how strangely something is behaving. So this is not a good hypothesis. How's this one? Fish leap from the water if there are donuts nearby. Well, that's actually pretty good. Our dependent variable is present, donuts are one of our independent variables, and we could test this by flooding the lake with donuts and watching the fish behave, how the fish behave. Be a terrible waste of donuts, but we could do it. How's this one? If there's trash in the water, fish are more likely to jump up and down. Well, pretty good, except the word trash is rather general. You'd want to be more specific and perhaps say soda cups. If there are predators like snakes nearby, then fish will jump from the water. Much better. Very specific. We used an independent variable of a snake, and our dependent variable is present. We could test this by adding lots and lots of snakes to the water and then watching fish behavior. Be kind of scary though. So finally, let's review. A hypothesis is indeed a prediction statement, but it must include your key components of the experimental variables, and it must be measurable or testable in some way. If you include those two components, you can never go wrong. Well, that's it for me. Thanks for watching. Oh, and by the way, if you're super curious about why fish really do jump from the water, check out this guy's website. Well, have a great day, and thanks again.